I'm Larry O'Brien, Vice President of Research at ARC. This is our session on integrated control and electrification. And for those of you that don't know what that means, it's basically just integrating the worlds of process automation and the electrical side of manufacturing. And that could mean a lot of things: switchgear, drives and motors, motor control centers, basically anything that's controlling electricity, or, in my view, consuming large amounts of electricity in the plant. And we have some great presenters today, but first you have to listen to me. We have Sandy Vassar from ExxonMobil, Alexander Mendoza from, it says SLA call here, but the correct name is, refresh my memory, BCP Group from Latin America, and we have Steve Kunzman from the IEC 61850 committee. He works for ABB, but today he's representing the IEC 61850 Standards Committee. And I just have a few introductory remarks. We hear a lot about cheap oil. Oil is cheap now, right? So why should we care about things like energy efficiency, and saving money on our electric power and so forth? At least that's the feedback I get from a lot of the manufacturers in North America. Although I can tell you for other parts of the world, energy efficiency is very much a big concern, particularly in industry which accounts for 1/3 of global energy usage, by far the largest consumer of energy in the world. Energy is the second largest expense for industry, exceeded only by raw materials. And various statistics show that industrial energy demand could increase by as much as 44% over the next 20 years. And we can see some of those facts and figures here from organizations like EIA and so forth. It's a big expense, and it's worth controlling. And this is a graph that I like to show whenever I talk about energy in the process industries. The process industries, which are kind of in this upper right-hand corner of this sort of quadrant chart here, are the most energy-intensive industries, which means that per unit of stuff that's produced, the process industries consume more energy than any other industry. And we at ARC believe that there is very easily probably a 10% cost reduction opportunity. It's very low-hanging fruit for the process industries, and a very good way to justify automation projects. If you can point to this economic bottom line, if we are going to save 10% on our energy costs. Implementing these projects can be another matter, but we'll hear about it in some of these other presentations. Now, this session is not just about switchgear, and heavy electrical equipment. We also have included a presentation about drives and motor control centers for a very good reason, because motors are the biggest consumer of power in industry. So more efficient control and usage of motors can have the greatest impact on overall power consumption for your plants. If you look at the strategy report that was also handed out when you got your packet of materials, there's some information in there as well about how much energy motors consume in plants today. It's very, very considerable. So this session is really about three things, and all of which have a powerful economic value proposition. We always try and stress the economic value of automation here versus just technology. If you were in the session this morning, you heard a lot about that. So the three things are the value proposition of the IEC 61850 standard to provide a standards-based infrastructure for power automation asset lifecycle management. We're going to look at taking a new approach to implementing and maintaining electrical assets that I think you'll find is probably similar to what we're doing on the process automation side of the business, as far as coming up with new forms of intelligent and configurable or characterizable I/O, compressing the time to project completion, and basically drastically reducing these project costs on the electrical side of the business, just like we're doing on the process automation side of the business. And I think you'll agree these project costs are quite considerable lately, and they're rising. And we're going to look at providing improved efficiency of drives and motor control centers and the integration of drives and MCCs with the process automation system. And this is ARC's vision of a good energy optimization strategy. It should include drives and motor controls, electrical equipment integration, Also things like production management applications, level 3 applications, optimization, advanced control, simulation, sensors and actuators, and of course the process automation system itself are all very good vehicles for reducing energy costs and optimizing your energy usage. They should all be part of any good energy optimization strategy. And I'm going to very quickly go over some of these last slides. IEC 61850, we have a whole presentation on that. A good way to think about this technology is kind of like a digital field bus type network for electrical assets, and a lot of the same advantages that go along with that. And some of the benefits of integrated control and electrification, of course, include standardization, being able to standardize procedures, settings, control logic, control libraries, lower investment costs by bringing simplicity to various stages of the project implementation, reuse of the engineering data, applying the same thinking to the electrical I/O that we do to the process I/O. And also, I think work processes probably can't be stressed too strongly either. Having some of these common work processes when we're working on the intelligent electrical assets, there's going to be a lot of commonality there in terms of working on intelligent assets on the field, on the process automation side as we see on the electrical side. So, and knowledge management issues, this is going to create a lot more information or a lot more data, I guess is probably a more appropriate term. So the question is, how can we turn all this data into useful information for the operator? And it's more data and more that needs to be turned into useful information for the maintenance people. How we use this information effectively is going to be a real challenge because, again, we don't look at just technology. We look at the people and the processes as well. Getting an accurate picture of your plant's energy usage is, of course, also important. I know a lot of end users out there probably don't have very good baseline measurements as to what their electrical usage is, and that's important as well. So, without further ado, I'd like to welcome our first presenter, Sandy Vassar of ExxonMobil Development. Please join me in welcoming Sandy to the podium.